Welcome to the Geophysical Institute, and thanks for visiting us today at the University of Alaska, Fairbanks. The Geophysical Institute is the largest research institute in Alaska. Alaska, to us, is one great big laboratory, and we study a wide range of phenomena that no one else around the country has access to right here in our own backyard. The GI was created by Congress back in 1946. They wanted a permitted institution to study geophysics in the Arctic. In the GI, we have a deep bench of experts in a variety of areas. We study the aurora, planets, we study volcanoes, earthquakes, snow and ice, glaciers, permafrost, and the strange weather we have here in Alaska. The seismology and geodesy department grew out of all the fascinating geophysics here in Alaska. Earthquake every 10 minutes. Geodesy uses GPS to study slow movements of plate tectonics. Seismologists deploy seismometers and other sensors around Alaska and around the world to measure the seismic activity inside the Earth. The Atmospheric Sciences Group, they study a wide range of phenomena in the Arctic. Alaska and the Arctic are warming 3 to 4 times the rest of the planet. So things are changing rapidly. They're trying to understand climate change and how it affects the atmosphere. The Remote Sensing Group uses a variety of platforms to study Alaska and the rest of the planet. They use satellites to study the Earth, unmanned aircraft, drones, and manned aircraft. We have LiDARs on aircraft. We have hyperspectral instruments on aircraft. And we do quite a bit of remote sensing around Alaska and around the rest of the world. The Snow, Ice, and Permafrost group, they study snow, ice, permafrost, and glaciers. There's a group that does sea ice and support others in sea ice research. We have several glaciologists who fly over or climb out onto glaciers to study them and look at how the glaciers are melting. We have several permafrost experts who study the permafrost extending across Alaska and even around the entire circumpolar Arctic. About 50% of the Arctic is permafrost beneath it. The Space Physics and Astronomy group, they study the aurora and the upper atmosphere. The definition of astronomy is the physics and chemistry of the upper atmosphere. A lot of the work is focused on the aurora, since that's a unique situation we have here, and we have our own rocket range. We do a lot of radio frequency observations with radars and transmitters like the High Frequency Active Auroral Research Program down at HARP. So we use GPS and high frequency radiation to study the upper atmosphere. So tectonics and sedimentation, these are the guys that study the Earth over very large scales and over very long times. Well, one of our scientists goes out into the Chukchi Sea to measure bathymetry and make magnetic surveys. Others study rocks. We have a geochron lab that one of our faculty uses to date rocks to see how old they are. What's happening in that area is becoming more important as the state takes more of an interest in critical minerals. So with our geochron lab and what we've just added, the advanced instrumentation lab, we'll be doing a lot of work to help prospectors come in from around the state and identify what minerals they've found and how old those minerals are. There's 54 active volcanoes, historically active volcanoes in Alaska, mainly along the Aleutians. There's 3 to 5 of them erupting at any one time. And so our volcanologists go out and install sensors to monitor the ground to get an idea when it's going to erupt. Sometimes they fly instruments through the eruptions to measure the gases coming out, or the precursor gases. And they use infrasound, GPS, satellites to monitor and provide alerts and warnings of volcanic activity. The GI is a fascinating place to study the Earth. A lot of our grad students spend the summer on helicopters flying around Alaska, digging holes, putting in new sensors, updating instruments, going out into the field to launch rockets or to fly unmanned aircraft. It's really fun to do this kind of stuff, and you learn a lot, and you get to understand up front, what does a volcano look like? What is permafrost? Not just something you read about in a book or see on TV. You can actually go out and experience it firsthand. That's a real advantage to coming here to do your research. Thanks for visiting the GI. I hope you appreciate what a fantastic geophysical laboratory we live in here in Alaska.